This is Calculus 12, Chapter 4.6, Related Rates. A 10-foot sliding ladder is leaning against the house. When its base starts to slide away, by the time the base is 6 feet from the house, the base is moving at the rate of 4 feet per second. How fast is the top of the ladder sliding down the wall at the rate of 4 feet per second? So we have our triangle shape here, which it shows all the data on it, and the question has already gave us x, which is equal to 6 feet, and we know d of x over d of t, which is 4 feet per second, and we're asked for d of y over d of t. Okay, so in order to find the derivative of y to the respective t, we have to take the derivative of x to the respective t and multiply it by the derivative of y to the respective x. So, to answer that question, we have to first find out our y value. So we have our x value, which is 6 feet. We have our hypotenuse, which is 10 feet, and we're looking for our y. So we use Pythagoras. So y squared plus x squared is equal to 10 squared. So y squared is equal to 100 minus x squared. So y is equal to 100 minus 64, and that will give us 8 feet. Okay. So now we have our y, our x, and we already had 10. So right now, because we have dx over dt, we have to find dy over dx. In order to find the derivative of y to the respective x, we have to take the derivative of y squared plus x squared. So y squared is equal to 100 minus x squared. So y is equal to root 100 minus x squared. So the derivative of y over the derivative of x is equal to negative 2x over 2 root 100 minus x squared. And we can cancel out the 2's, and we'll be left with negative 1 times x, which is already given, which is 6, over root 100 minus 36. And that would be negative 6 over 8, and which is negative 3 over 4. Okay. So we have our d of y over d of x, and we already had dx over dt. So we now can find dy over dt, which we just have to plug in our numbers into the equation. dy over dx. So that will be negative 3 over 4 multiplied by 4, and that will be negative 3 feet per second. And that's our final answer.